Good afternoon. The title of my talk is Mechanisms of Attentional Priority in Working Memory are Context Dependent. So as we all know, working memory has a limited capacity and is also short term. So we need a way to be able to juggle between the different representations and information in the working memory in a way that is segregated but independently accessible. For example, like a server in a busy restaurant that has multiple tables, how they update all the information based on their relevance at the time or their intended goals very rapidly. So in the study, we're trying to understand these mechanisms better and especially focus on the process of removal. One of the most useful ways to study these mechanisms is the use of retrospective cues. Here is a simple example of how retrocues work from our earlier spatial memory study. Participants were presented with two colored discs. Midway through the delay period, they were either presented with a 100% valid cue that told them the location of which discs they were going to be asked, or a neutral cue that was completely uninformative. What we found was that performance was significantly better when people got a valid cue compared to when they got a neutral cue or no cue at all. And this is known as the retro cue benefit. So in the study that I just mentioned, we recorded EEG to be able to visualize and reconstruct working memory representations and to see how retro cues can influence the quality of these representations. What we found was that before presenting the cue, the quality of memory representations kept going down up until cue onset. After after presentation of the cue, which is where the line splits from purple to black for uncued location and green for the cued location, as you can see, we observed a rebound for the cued memory representations while the location information for the uncued location continued to go down. And it also showed that retro cues can mitigate that information loss, and people are able to partially reverse the information loss after receiving a retrospective cue. But we've known for a long time that retro cues can influence how people treat the cued memory representation, and there are also some evidence on how retro cues influence the way people treat uncued representation or the task irrelevant information. They're both behavioral and EEG data showing that under certain circumstances, when you give people retro cues, they try to actively remove irrelevant representations. That can help them in different ways. For example, free up additional storage capacity in working memory, or eliminate interference with relevant representation, and that way it can improve their memory performance. In this experiment, we changed 50% of trials to 100% invalid cues, meaning that in half of the blocks, the cue tells people with 100% certainty which location they will not be asked about. And the question that we're trying to answer here is whether people treat the cued and uncued memory representations differently based on what aspect of the cue we were emphasizing. So basically, we're asking the question, does that simple difference change the way people treat cued and uncued representations? So we recorded EEG while participants performed a spatial memory task. On each block, we presented two colored discs, one red and one blue. They would appear randomly in one of 8 possible locations for 500 milliseconds. Halfway through the delay period, the fixation point would change color to either purple in neutral trials or to blue or red in valid or invalid trials. The results of our behavioral data showed higher precision for both valid and invalid trials in the blue bars here relative to the neutral trials. but we didn't find any significant difference in precision between valid and invalid cues. So there was no effect of the cue type. Reaction time was smaller in cue trials compared to neutral ones. Also, people were more likely to swap or confuse the two locations in a neutral compared to cue trials, but there was a small difference between invalid and valid, but there were insignificant differences. And also, people were a little more likely to drop or forget the location in invalid trials compared to valid, but that difference was also pretty small. So overall, task performance is largely the same for the valid and invalid retrocue condition from a behavioral standpoint. So what makes this study different from previous retrocue studies on directed forgetting is that here we're able to visualize and quantify visual working memory representations over time. In order to do that, we applied a spatial inverted encoding model to the patterns of alpha band activity. So we train the model and then we get a set of weights that tell us how much each of the electrodes respond to each of the eight possible stimulus positions. And then using these weight profiles, we inverted the analysis and computed the response of each channel. Then trial by trial reconstructions were shifted to a common center. That would yield a time resolved reconstruction for each participant. But convention, we shifted everything to 0 degrees so that the peak of this plot here is in the middle on 0 degree. Then we took the representations on each time and projected them into a circle and computed the vector length. That the vector length gives us a fidelity metric, or basically the amount of location information to make it easier to visualize. So here we can see that our analysis is reliably tracking the remembered locations, because as we can see, there's a strong location-specific signal following the onset of the stimulus that persists throughout the trial and progressively weakens over time. So now we are sorting these by cue condition. Here we see what happens during the valid blocks. We see basically what we saw in previous studies. So when we give people a cue, we see much more information about the location that matches the cue compared to the one that doesn't. This window here is the last 500 milliseconds of the delay period. So we just average the fidelity estimates within this window. And as you can see, there's a lot more location information for the cued location compared to the uncued location, which is consistent with all the previous findings. Now in invalid blocks, we did the same thing, and we see a flip shortly after the cue onset. And again, in the 500 milliseconds of the trial, there is much more information about the location not matching the cue compared to the one matching the cue. So here in this graph, we're also showing fidelity as a function of time, but instead of having matching and non-matching, we took both of the task irrelevant stimuli, being the one not matching the cue during valid blocks and the one matching the cue during invalid blocks. So both of these are the items that participants should be ignoring or be forgetting. What seems to be happening here is that shortly after the cue comes on, in case of valid condition, which is the red line here, it looks like overall memory fidelity continues to decrease with a relatively constant slope over the course of the trial. But in the invalid condition, there was a brief boost after cue onset, followed by a steep decline. So we took this period of between 1600 and 1800 milliseconds and compared the slopes of the two lines. During the invalid condition, the irrelevant item has a much steeper slope, being 5 units per millisecond, relative to the valid condition, which we can conclude that it could suggest an active removal or suppression mechanism. And next, we try to see if this ability to suppress or remove the irrelevant information varies across people and is it related to their overall memory performance. So we took our 40 participants and split them in half based on their median response time. For the fast responders, the slope of this decrease in location information is much steeper than people who responded very slowly. So, to summarize, our behavioral data didn't show a significant difference in performance between the types of cue, but people were a little more likely to swap or drop when they were given an invalid cue, but those differences were pretty small. Our EEG data, however, shows clearly that subjects were treating the task irrelevant items differently based on the nature of the cue. And valid and invalid retro cues seem to engage different attentional mechanisms. During valid cue, we see more of the prioritization of the matching item, and for invalid cues, we see a lot more of the removal or suppression of the irrelevant item. Therefore, we can conclude that mechanisms of retro cue benefits are likely to be context dependent. And finally, I would like to thank our funders, my school, Florida Atlantic University, my advisor, Dr. Esther, and all of you for your time today.